Right, so number 4, again, instead of an equation, you're just given velocity and acceleration values in this chart. So all the numbers that we're going to need to use are right here. So let's read. Table below gives values for velocity and acceleration of a particle moving along the x-axis for selected values of time. I don't see any units for this, so that means we're not going to need to use them. Both velocity and acceleration are, differentiable. Hey guys, if they're both differentiable, what does that mean that they also are? If they're differentiable, then they're also what? You can abbreviate, I know it's a long word. Yeah, there we go, good, continuous. Awesome, you guys rock. Okay, if our functions are differentiable, they're also continuous. Velocity is decreasing all the time, and we can see that 5, 3, -1, -8, those values are going down. Use the data to answer the questions. All right, so cool. Is there a time when the particle is at rest? Explain your answer. All right, at rest would mean that velocity is 0. So look at these velocities, guys. Just by a yes or a no, do you think that there's a time when velocity would have to equal 0 somewhere in here? Just a yes or a no. What do you guys think? Will velocity have to equal 0 at some point? And yet it will. It'll have to equal 0 sometime in here. 0 is going to have to be in between those two velocities. And the reason why is since the function is continuous, that means there aren't any asymptotes or holes or breaks or gaps in the graph. And so 0 is going to have to be in between those. So you have to say all of that in a sentence because it says explain. So it is a little bit of writing, but it's not that bad, okay? We're going to say velocity is differentiable. So it is also continuous. And you have to say that on the AP exam. They make you write that out. And I'm not going to take off for your spelling, but differentiable is going to be written in the problem somewhere. So you can always copy that one. But velocity is differentiable, so it's also continuous. All right, so period. Just make that be a sentence. All right, and so since 0 is between what were the two velocities? 0 is going to have to be in between here. So since 0 is in between v of 2 and v of 6, 0 has to be somewhere in between those. There is a time on 2 to 6 when velocity equals 0. It has to be in there. Because the function's continuous, and if we've got 3 here and -1 here, then 0 is going to have to be in between. All right, so it's a little bit of writing, but we lived. All right, letter B. At what time indicated in the table is the speed decreasing? All right, again, people will just look at acceleration, but you have to look at both velocity and acceleration. So slowing down, speed decreasing means velocity and acceleration are opposite signs, and that's going to be our explanation, is that they're opposite signs. So let's see, at what time, I'm going to ask you guys this one, let me erase my circle here. At what time is velocity and acceleration opposite signs? At time what? Yeah, good, nice guys, right here. At time 2, velocity is positive and acceleration is negative. So t equals 2 because velocity and acceleration are opposite signs. All right, cool. And then we're just going to try one more. All right, a car is traveling on a straight road, and this time we're given a graph. For 0 to 24 seconds, the car's velocity, so we're given velocity here, in meters per second, and the units are always a clue. If you have something per something else, then it has to be a rate of change. Is modeled by, and then they throw this vocabulary at you, piecewise linear. Just means you have a bunch of lines, So like, look, a line, another line, and another line. That's all that that means. Don't let that bother you. All right, so for each of v prime of 4 and v prime of 20, find it or explain why it doesn't exist, put units. All right, so let's look for v prime of 4. We're trying to get the derivative at 4. So here's 4, and we cannot get a derivative there. I cannot get an answer. So I'm going to say v prime of 4 does not exist due to, what's the problem here, guys? Why can't I get a derivative at that point? Like, what is the matter with that? And yeah, good. I was waiting for somebody else to answer too, but yeah, good to due to a sharp edge. This slope is positive, and then this one is 0. The slopes from each side are not matching up. All right, and then v prime of 20. So we're trying to get the derivative at 20, which means the slope. Here's 20. And so we want it, what we want is the slope of this line. All right, so let me zoom in a good bit more. This one's hard to see because there's not really a grid here. We want to see how much we went down and how much we went over to get the slope of this line. So we went down 20, so negative 20, and then over from 16 to 24 would be 8. So we went down 20 and then over 8. So that would be negative 20 over 8. You don't even have to reduce that. You can leave it alone. But we do want units. Velocity was meters per second. So since we did a derivative of that, its acceleration, it will be meters per second squared. So if this is velocity and we do a derivative, then that is acceleration. All right, letter B. Let A of t be the car's acceleration in meters per second, for times 0 to 24. Write a piecewise defined function. All right, this gets people because it's piecewise, but look, there's going to be 3 pieces to the graph, 1 for each of these lines. And acceleration just means the slope. We want the slope of these lines. So here, let me zoom in again. So the slope for this first line, we went up 20 and over 4. So from 0 to 4. So we went up 20 and over 4. So 20 over 4. And you can write 5, that would just be 5, but you don't even have to reduce that. And the portion of the graph for that is from 0 to 4. So from times 0 to 4. All right, and then, hey guys, what is the slope for the next section? Because again, we're trying to do the derivative of this, so we just want slope. So slope for this section would be good, 0. And that is from 4 until 16. So from 4 until 16. Now I'm going to put the equal to's on those ones. Let me finish this problem, and then we'll go back and have the conversation about the equal to's. All right. And then the last one, the slope of this line, we found that already. It was negative 20 over 8. And so that is from 16 to 24. So I didn't put equal to on the 0 and the 24 because it's not given in the problem that way. So I kind of just went with what the problem said. As far as the 4 and the 16 goes, you just need to include an equal to somewhere. And it doesn't actually matter which one you put it with. Like, for example, I could have put the equal to with this 4 and left it off of that one, or vice versa with the 16. It really doesn't matter as long as you include it somewhere, because if you don't put it somewhere, that means you left out that point. So you just have to include it somewhere. It doesn't matter where, though. All right, and then last one, find the average rate of change. That just means slope. This is back from unit 2, average rate of change of velocity, which is the graph we've got here, on the interval 8 to 20. So we want a point for 8 and a point for 20, and we're just going to do the slope. So let me get those points from the graph. All right, so here's 8. That point on the graph is at 20. So we'll have 8, 20. And then I need to get the point for 20. So 20 is right here. That point on the graph is at 10. So 20, 10, and then just do the slope. It'll be 10 minus 20 over 20 minus 8. You don't have to simplify. Just subtract the y values, subtract the x values. But we do want units. So velocity was meters per second. We did a slope of that, so it's going to be meters per second squared. It's an estimation of the acceleration.